Okay, so let's do another one. So again, I'm going to use the same template. So find the region of the solid obtained by rotating the region. We're going to change the region a little bit. Okay, so our region is going to be bounded by y equals x, y equals square root of x, and we're going to rotate it about, this one's interesting, x equals 2. Okay, so let's see what changes with that. So step one for every problem I give you is, by now you should know. If not, then by now you should know. Draw the picture. So y equals square root of x. Looks like so. I don't like that one. Let's try that again. There you go. Let's move it a little bit. There we go. Okay. That's equals y equals x. Y equals square root of x. Y equals square root of x. Looks like so. Let's try it with the shape completion, see what it does. Yeah, it's all right. Okay. Now, these points here, this point here is 0, 0. This point here is 1, 1. So actually, in either case, no matter how we integrate it, it's going to be, those 2 points are the same. Okay? X equals 2. X equals 2, that's going to be over here. Let's try that again. Okay, so now, all right, let's do this. First, let's set it up via circular disk. Yes, circular disk. Okay, so if we do that, I'm going to need to say this is an annulus problem. So I need the center, inner radius, outer radius. The center, that's very clearly x equals 2. Okay, inner radius. Now, inner radius is this distance. Okay, that's distance is going to be 2 minus x. Okay, think right minus left. Okay, actually, if you wrote down x minus 2, in this case, since we're squaring it, it's not going to really give a problem, but let's just, for the sake of doing things right, make sure we have that right. Okay? The outer radius is going to be 2, again, minus, well, this is y equals the square root of x. Uh-oh, uh-oh, uh-oh. That should have been y. Why should it have been y? Because we're going to integrate this direction. We're going to integrate in y. Okay, so this is now going to be, if y equals the square root of x, that means x equals y squared. Okay, so if we're doing this by cylindrical or circular disk, okay, again, if you're doing it by circular disk, it's not a bad idea to also say, hey, I'm going to do it by circular disk. That way we know. Okay, I have my inner radius, I have my outer radius, I have my center, and I can just set up the integration. From 0 to 1, pi 2 minus y, 2 minus y squared minus 2 minus y squared dy. Again, this is straight up, straightforward polynomial integration. There's nothing crazy here. Okay, let's see if we could set this up via cylindrical shell. Okay, so cylindrical shell, we're going to integrate from 0 to 1. Okay, it actually, I'm not sure if it's going to give us, so I think that it's a better idea to integrate from the inner to the outer, but I'm not sure because we might get a negative, and so I'm a little worried about that. But let's go ahead and integrate from the inner shell to the outer shell, okay? Instead of integrating this way to this way, we're going to integrate this way to this way, okay? So we're going to integrate. And the reason I want to do that is because even though y moves from here to here, the volume of the inner shell, the volume of the inner shell should be less than what it is when we go to the outer shell. Okay, so we're going to integrate. X goes from 1 to 0, okay, 2 pi. Now, what is our r of x? We should write that down somewhere. Our r of x here is going to be 2 minus x. So our r of x goes from 1 here to 2 there. Okay. Next, we're going to take our h of x. H of x is top minus bottom. H of x is going to be square root of x minus x. Okay? Because it, like say here, the top is square root of x minus x. Okay? All right. Now, there's one more little wrinkle we could have done here. If we didn't like this, we could have just moved everything, right? We could have moved everything. We could have said, okay, well, let's instead of x, let's redraw it. Okay, let's do a redraw of it. Okay, so let me put it on the same thing so that we can see. We want to redraw it about x equals 0. So what we're going to do, we're going to call this like u equals x minus 2. Okay. So then we're just drawing everything over here. Okay. Which is the same as if we had drawn everything over here. Okay, so there's a couple of different ways we could have done it. Let's go ahead and go with this one because it follows easier from the math. So we could have said find the region of the solid obtained by rotating, find the volume of the solid obtained by rotating the region bounded by. Now, what have we done? U is x minus 2. So instead of y equals x, we're going to have y equals u minus 2. That's this. Y equals u plus 2, because u is x minus 2. Should have realized, right? The reason I realized it, okay, was because u minus 2 is definitely not this line. But this line is u plus 2. Okay? This line, however, is u minus 2, but we'll worry about that some other day. Okay? Y equals square root of x plus 2 about the y-axis. Okay, and that is actually geometrically equivalent to doing this one about the x-axis. Okay, so that's going to be what? Y equals u minus 2, y equals square root of x minus 2 about the y-axis. Okay, think about this. This point is negative 2, so by geometry, this point should be x equals 2. Okay. Oh, no, that's wrong. Actually should have been like this. Forget this one. Wrong, because it should have been like this one. Oh, that would have been hard. But it's still not that crazy, okay? It's not direct. Okay, so that would be what? Y equals negative x plus 2. Y equals negative square root of 2 minus x about the y-axis. Okay? That should also give us the same thing. Okay? Honestly, this is how I would expect you to do it. Okay, one of these two ways. But these other options are open to you. All right, I'll see you all in the next video.